This video is going to go over linear functions with model data and what we can do to find some data trends and like real world situations. So we're going to look at a scatter plot, and this table here shows the number of chirps in 15 seconds at different air temperatures in degrees Fahrenheit. We want to plot the data. So a big question here is, do we think that chirps depend on temperature or that temperature depends on chirps? And the correct answer there is going to be that the number of chirps should depend on the temperature. It's not like the world listens to the number of chirps and then heats up or cools down based on that. So I'm going to put chirps on my y-axis and temp on my x, and it looks like my temperatures go from about 50 to 80. So I'll do a little break in the graph. 50, 60, 70, 80. And then it looks like my chirps go from a little less than 20 to a little more than 40. So let's just go by tens. 10, 20, 30, 40. All right, 44 and a little bigger than 80, 35 and a little bigger than 70, 20, 57, 33, 66, 31, 68, 31, 68, 35, 72, 18.5 and 52, 37 and 73.5. Let's see, it's going to be a little bigger and a little higher. It's up here. And then 26 and 53. Now, it says, do this data look to be linearly related? Well, you can see it definitely looks like the number of chirps increase as temperature increases. So I would say yes. Some data might look curved, like it might look like this. This doesn't do that. It looks like over time, this isn't exact, but it's pretty close. So one thing we can do as well is we could put this in like a software program, and in that software program, it would allow for us to find the exact regression line. But let's talk about how to approximate the regression line. So one way that we can do that is we can just kind of use like the lowest data point and the highest data point and see if we connect the line between those 2 points. Do we feel like that line is a good model for this data? Does it kind of go through the middle of the data points? And in this case, it does. So I'm going to use my highest data point and then my lowest data point. Now remember, I want to do change in y over change in x. So I want to do change in chirps. Let's do 20.4 minus 44 over change in temp, being consistent here. Grab my calculator. 20.4 minus 44 gives me negative 23.6. 57 minus 80.5 gives me negative 23.5. Oh goodness, that's pretty close to 1. It's like 1.004. So if I even round to 2 decimal places, I'm just going to say that the slope is 1. So interpretation of what that means in context is as temp increases by 1 degree Fahrenheit, right, the number of chirps in 15 seconds increases by 1 chirp. And then I can like write an equation for that line. I can use either one of these. So y minus 20.4 equals 1 times x minus 57. And so that might be an approximation that I could use. And so that way, if I knew, like, hey, if the temperature is 60, how many chirps per minute could I expect to have? Because I have a regression line or an approximation line to model this data.